And CAD program, the computer aided drawing program, is being used, and the process was initiated in 1980s by Charles Hull and the Japanese doctor. So this is successive addition of layers of material on one onto the other. On one onto the other, a successive layer of material is being drawn. Other than using traditional methods, that was subtractive materials, subtractive methods. So this is a basic 3D component 3D printer, and there are many types of printers available. So if we talk about inkjet printers, if I hope the first figure is visible. So in this, the down part, this arrow part, if we see, is the base, and here a roller is being applied to this base material, right? And a roller is being applied, and here this inkjet head is there, that, and this orange highlighted part is the material that we are preparing, and here sideways is the supporting powder, so that it supports the whatever we are inputting on it. The roller here provides the raw material that is in powdered form. So here this is the input material, the raw material, and here a fully 3D object is being prepared. So next is next type of 3D printer is the fuse deposition process, fuse deposition modeling process, in which the rollers here, the support material, the rollers are here, and the build process is made on this tabletop, and here the liquid is being used. The liquid is being used here, and the work is being done. This is also one of the type of additive manufacturing process only, where this, if you can see, it is the product is made up in the product is made up in X, Y, and Z direction. All the 3D model is being prepared, and here foam slab is there just to support the material, right? Then third is the stereolithography, where mirror is being used as for UV rays, and there is an elevator, there is a sweeper, and then lastly there comes a selective laser sintering process. Here laser light is being used for the scanning purpose, and the powdered material where part is being built, and here again the our raw material is in powdered form only. So powder form, the wire form are the basic forms of the material, raw material being used. So the major steps we discussed earlier. First is the development of material, which material we want to use, which material we are using. Let's suppose we are using powder or maybe wire. So a CAD model is being prepared. CAD model is being prepared using these softwares, maybe AutoCAD, maybe SolidWorks, right? And if in the figure, if you see very clearly, it is mentioned here X, Y, and Z direction, right? So all the three components, the mug here, the vase here has some width, has some length, and has some thickness also. This is the first step of customization. Customize means what we want, what we think in our mind. So this is the first step. I want a pink color vase. I want a green color flowered mask, anything. So whatever is in your mind, you just prepare a model for that. Then the file is being saved in a .stl format. As I told earlier, .stl, that is that is standard triangle language here. So this, if you can see clearly, the dimensions, the vase is clearly divided into small, very small triangles. And then this is a sliced layer. That is means addition of layer, how material is being added from base, then to the top a small material is being added. This is the again 3D printer for the development, and this is the final product. Here the product being we are getting in white color or the off white color, but if the raw material is of green color, the wire is of green color, the powder is of red color, any color, any design can be prepared using this particular method. So first part and the best part is we can post after processing, after the object is being made, we can do post processing methods also, like we do in traditional methods, the grinding, to get the proper required surface finish. So this also, in this technique also, additive manufacturing, we can convert, we can clear the raw material if anything extra is added to that, right? So then next comes the forming and modeling. Again, the steps are being mentioned here. Mention means they are detailed. Model is being prepared using a CAD software or a scanner. Then modeling is done like whatever we design, whatever is in our mind, and then the printing part is there. After the thorough finish, the printing is slightly oversized in the standard resolution, and extra material is being removed to obtain the required accuracy, the required precision. Obviously, a little bit tolerance is there. Sometimes tolerance is added, and sometimes exact product is being made. So then comes the sintering, melting, and lastly the stereolithography. Sintering is material is heated, but not up to the point of melting point. It is into some semi-solid form. Semi-solid form is generally used for uh, for the process as a raw material, so that it can be flown very easily. Have you seen that hot glue gun? The glues are in form of small cylinder, pencil form, pen form. They are small sticks of glue, and when they are inserted in the machine, the small gun machine, they come into liquid form. So there is some heat energy being introduced, and the material is not heated up to its melting point, but up to a certain level, right? And then melting parts come. Melting part, there are many different methods for melting of 3D printing models like powder bed fusion, electron beam, direct energy deposition is there. There are many other methods also. Then comes this stereolithography where the object is solidified into thin layers, and it is and a cross sectional object can be observed. Raw materials, as I discussed, we generally say plastics are not to be used anymore. Plastics are waste of material. But these plastics can be used and reused again and again to manufacture the customized products, the products what we want, the designs what we want, the shape and size, what the dimensions what we want. So powders can be used, some resins can be used, metals also can be sintered. Metals can also be brought up to their melting point and then can be used. Metals generally like stainless steel, mild steel, gold, titanium, carbon fibers, that includes graphite and graphene also, and ninotol, that is a mixture of two components, nickel and titanium, for medical implements. Similarly, composite materials, similarly ceramics, many types of raw materials can be used. But the most general part of raw material being used is the plastics. Plastics is the one of the basic raw material that can be used in any of the forms, right? Then comes the benefits of these additional additive manufacturing technique. Benefits, obviously, it is a very new technique. It is it is almost 3 decades back, but it has very high benefits. First and the major most benefit is the customization part. Then that is recycling of waste material. Then there is improvement in the cost and the time, the effort the particular person is implying in that. The speed of designing, the speed of fabrication, because within a single design, with a single design, multiple objects can be made if if the raw material is inserted, if the raw material is in powdered form, it is inserted time to time. Very high speed can be observed. There is very low or minimum wastage of material because layers are being added to get the exact height, the exact width of the product. There is no cutting, there is no reducing of the path. That is why it is termed as additive. And one of the best part is it has minimum inventory risk because raw material can be used once, maybe raw material can be used again and again. It can be recycled also, and it gives the aesthetic a pleasant view of the object what we have designed and what we want is. So to list a few, I have written like affordable startup cost. Means if I want to start my business of customizing pens, business of customizing pencils, bottles, mobile covers, anything. Have you seen nowadays the resins are being used for the 3D models that solidify, and your product or the medal is being created, the pendant is being created, earrings are being prepared. So multiple uses of this additive techniques are being there. one for customized hair. There is rapid, there is instant models are being prepared. Let's suppose, for example, there we have to make a hydrothermal power plant. We have to install a big machines on the planer machines, milling machines in a workshop. So we can't design the plant layout. We can't design on a paper and say that this machine will be kept here in this section. This machine will be kept here. Grilling will be done. Then surface grinding will be done. That is not a part of on paper. Nowadays, it has been computerized and we small models. If we have ever entered a big hotels or restaurants, we can see on the at the entrance there is a big layout of whole of the property that is being under that area. The whole dimensions are being there is a one building, then there is a green area, then there is a lobby. Means at every hotel, even in the hospitals nowadays, a full layout of the area is being mentioned at the entrance only. So that is not how that is the project work that is being done by school students using this additive techniques only. It is not that big interior designers are making that thing, nothing like that. It is just ease of preparation. Ease, if the students, if the person has a full layout of the property that is there, the hospital, the hotel, whatever it is, the small instance can be made very clearly. Very, we don't make the whole hotel in one night, but we can make the whole idea on from pen paper to that 3D model in just 1 hour. So that is the transition. Earlier, what our ancestors had, the machining operations, the things are being revolutionized. The things are being using technologies, new techniques. The things are becoming more easy with minimum wastage, with sustainable development is being nowadays promoted. So their products are being prepared, are biodegradable. The products are eco-friendly, and the major thing I forgot is the complex symmetries. If we have to make very intricate, very complex designs, that can't that is not possible using those traditional methods. Using that lathe machine or the milling machine, the products are not possible. Even using ECM or the non-traditional techniques where tool and product are not in contact, direct contact, so that is not possible with them also. So for that purpose only, we are using complex geometries, the intricate steps, the interior. If there is a hole in between, the hole is narrow or the hole is wide, or there are steps within a part, the interior designing part. So these complex geometries can be very easily made using these additive techniques. But everything has pros and cons. Everything has boons and bane. So here additive also has some cons, some limitations. Limitations is as compared to the strength. When compared in strength, conventional methods are more beneficial because they are made from tensile steel. They are made very robust. They are very hard, very tough. But here the product is being made using plastic as raw material. So these are not as good as the other ones in strength and in hardness. And it has increased cost at high volume. When the number of products are being raised to a higher level, the cost of the raw material, plastic, is not so costly, but the machining cost, the things that go on to a higher cost there. Then accuracy is limited in this case. When multiple products are being manufactured, accuracy gets to a limited space, precision is minimized. Just because it's not like कि machine thak gayi hai, it's just because the same process is being repeated and repeated again. Post processing requirements is again and there. If there is extra powder being pasted here, or if in let's suppose in lamination, sometimes the sheet gets extras on outside, so we have to cut that extra part. So that is a post processing requirement. We generally need that. Then there is reduction in manufacturing job where the laborers had continuous 8 hours, 10 hours, 12 hours shift. When jobs are being reducing, as just one single person can observe a small tabletop machine which is producing multiple projects, multiple products. So there is a reduction in jobs also, just like just like when initially where to operate late, there are 4 to 5 people for different operations, but in this, just one single person is required. And then there are regulatory challenges because the material is being developed in all the 3 dimensions. So a regularity check is to be there, what are the dimensions are being required and what are being prepared, because this is a customization work. It is not like okay, whatever you think, whatever you do. It's not like just a customizing what the customer thinks is always right. So here also customization is being done. So regulatory challenges are there. Now the 3D, it has application in every field, including the automobile sector, medical sector. The robots are being prepared. Then there are customized parts, the research and educational purposes. Much of the research is being carried out using these additive techniques. What all new can be done, what all novel techniques can be applied, then in construction, then in customization, as I discussed, then in military, the defense purpose, because lightweight materials are being required. Aerospace industry, the aeroplanes, the military jets have their outer coverings made up of aluminum, the seat covers, the designs. These all can be made using 3D application using the additive technique. So the market for this is developing, and market for traditional is constant. It is neither developing nor reducing. But market for additive techniques is definitely developing, and in coming years, it may not replace the traditional methods because they are evergreen, but it might take a bigger stand on in the market. So here are a few examples. The first example is of the gears. Gears we all have heard of. गियर्स जो हमारे नॉर्मल रिस्ट वॉच में भी लगे होते हैं, हमारी गाड़ी में भी लगे होते हैं, हर जगह हमारे जहाँ पे भी टर्निंग मूवमेंट आ रहा है वहाँ पे गियर्स हैं. देयर आर नंबर ऑफ टाइप्स ऑफ गियर्स. सो रिस्ट वॉच से लेके गाड़ी तक एवरीवेयर देयर आर गियर्स, राइट? So that tickling of clock is also due to action of gear movement. So here these gears are made as models for the actual product to be prepared. These are just the prototypes what actually can be made using additive technique, right? Then is the exoskeleton arm. Exoskeleton means if you can see, it has fingers and it has a wrist, right? It has a palm also here in the between. Exoskeleton means when a worker in the manufacturing area workshops cannot lift a load up to 50 kgs or 100 kgs or 25 kg. I mean, heavy loads can't be lifted by human beings, right? So there are different aged workers in the market, in the workshop. So they can't, everyone can't lift a very heavy or heavy load. So these exoskeleton arms, just putting them like gloves, we can handle up the load up to very high weight, up to 100 kgs maybe. So these just are like human gloves, which help the person doing the work. So these are manufactured products that can be actually used in industry and are being used in industry. This is a very old, or you can say a decade old project being done by a student. And then is the toys. Toys are customized toys. One baby needs green and red combination. One baby needs pink and purple. One baby needs blue and green. So there are different combinations can be made. So different toys can be made. Different colors, different designs can be made using this additive techniques only. It has very high features like speed, instant products, instant models can be prepared. Then flexibility. We don't want thumb for an exoskeleton arm. We here in this case we want a three-wheeler. In that case, there is flexibility in design. Competitive advantage because using traditional methods, the accuracy, the time consuming, it's not as easy as in the additive technique. Then comes the tangible designs. Tangible means again that comes to interactive or complex designs and the testing of the product. Quality is definitely ensured because raw material is good. Then there is consistency and there is very low risk that product might get fail, Because low risk, because it is just one product and it is a customized product. If we have made a vase of, let's suppose, green and pink combination, right, with flowers on it, tulip flowers on it, but it doesn't look aesthetically very nice, a decorative one, so we can change that. So there is a very low risk that mass, there is no mass production, there is batch production or job production. So there is very low risk in that case. And to get these products more beneficial, 3D printers, 3D parts are being coated. Coated are being just like last time we had discussed with tribological applications. Here, these 3D parts, like here in the first slide, if, here also if you can see, the product is made up of off-white color, right? Here the product is of off-white and black color, the toy car. If in starting I show you here the mug version of white color. So these objects, if they are being colored, if they are being decorated, if they are being coated, like just we coat our nails, nail paints, right? We coat the walls of our house just to give them a grace, just to give them a decorative look, to enhance the product that we have made. So this is also again that thing that these products can be coated, these products can be printed, these, just like we, have you seen the water bottles having kids name on it, the name of kids on their tiffin boxes nowadays? It's in a trend, it's in high trend. So these all are just using coating, just using different color combinations and giving and coating the layer with that particular name, with those particular alphabets, with those particular designs. So these are coatings to just to embrace, just to give a decorative, beautiful look to the entire workers, and definitely enhances the work life also. So this was all for my presentation today, and I hope you all had a great time, because this is a really new topic, a really new thing that many researchers, many scholars are working on it, and daily. If you see, if you go to some journals, if you go to newspapers of these additive techniques, you find every day something new and interesting is being built upon, and that is being used generally. Let's suppose if we talk about pen, a knife, whatever you talk about, that can be made um, using those additive techniques. Firstly, what we had, those Natraj pencils that were red and black, or the Apsara pencils that were black in color. But now, if you have seen kids' pencils, they have cartoon prints on them. So that is again an additive technique. That is again, the coating has been done using cartoon prints on that. Earlier, we had wrapping paper, the gift wrapping paper, simple golden, silver, red, and black. But now that paper material is also coming. That is a development of how traditionally the things were being used, and now how the technologies have revolutionized our world, our things that have taken apart. So I hope that was a little good, a little. Hope you all had a great time in listening to that. If you have any queries related to this topic, please go ahead.
Thank you very much, madam, for your wonderful presentation. Now I request the all participants, please, if you have any query regarding the today's topic, please ask, madam will answer it. Dear participants.
Yes, sir. Please, if anyone of, because
तो
this is
मैडम,
a and yes, sir.
नमस्ते मैडम। मैडम, आपने एक टिटेनियम की बात की है। टिटेनियम जो पाउडर है वो लगभग सभी प्रोडक्ट में यूज होता है, इस्तेमाल होता है।
Yes,
तो
sir.
क्या इसकी जगह कोई और भी पाउडर हो सकता है कि उसकी जगह ले ले?
Chromium has chromium powder hai. Titanium is used for wear resistant properties, right? So chromium is also having same wear and resistant coating. So that can be used. A combination of nickel and chromium can be used. Steelite के different codes as a steelite 6 है, steelite 21 है, that can be used. So there are alternate options with again having some maximum benefits and a few prawns, like maybe you can say cost and availability. Availability of raw material is a challenge. So it is not available everywhere. But yes, in North India, we have in many industries that are using this chromium, titanium, so we can get them easily.
दूसरा सवाल पूछा, सबसे ज्यादा कहाँ पर मिलता है टिटेनियम, मतलब हमारे देश में या बाहर के देशों में? अगर इसके बारे में जानकारी देंगे तो धन्यवाद। और क्रोमियम के बारे में थोड़ा सा।
टाइटेनियम सर, हेलो
मैडम। हाँ जी मैडम।
सर
सबसे ज्यादा कहाँ पाया जाता है, किस देश में मिलता है?
सर टाइटेनियम इंडिया में अवेलेबल है इन साउथ, मैक्सिमम इसकी अवेलेबिलिटी साउथ में है, नियर केरला सर।
क्रोमियम?
क्रोमियम आई एम नॉट सो श्योर, बट सर क्रोमियम जहाँ तक मुझे अंदाजा है ये गुजरात एंड दमन दीव वाली साइड, उस साइड है सर हमारे।
धन्यवाद मैडम। थैंक यू मैडम।
नो प्रॉब्लम सर। Thank you, sir. Thank you again for giving me this opportunity. And indeed, it was very great to interact with you. Thank you, sir.
Hello. Good evening, ma'am. Good evening, Dr. Dekkar, sir. Prashant, sir.
Good evening, sir.
Thank you very much. This is a very new topic and new thing for me, and definitely it has developed a vision in this section also. I think that the coatings, what I have received, that coatings we are talking about. So sometimes we are using it for the purpose of. Sometimes we are doing it for the purpose of to enhance the look of the matter, and we can go with the three-dimensional nowadays. Cups and mugs and ornaments, they are coming in a three-dimensional structure, so it is very much possible because of that. That is one thing. Another thing is, we are using some iron instruments or something, and we are painting them with a color, so they should not catch a rust. So that is also kind of additives, what we can call it as. And any other instruments where the coating is done for some other reasons, for preserving the things or some increasing the potential of some other aspects. So it is only for the sake of what Nataraj pencil was looking first, and now we can get all kind of picture and more better it appears for the students. So that is the only thing, or it has some meaning in some industries, in health sector, like that. I want to know that. Thank you, ma'am.
Sir, here we have confused two things. One is the additive and one is the coating. Additive is a technique to build up a product from raw material that is in powdered form or in wire form, right? So additive is a technique to build up a object in 3D model that we had designed using a software to bring it into life, to bring it handy. And coating is coating if we are using generally, let's suppose nail paints or the coating for walls for if that is a second. Firstly, that gives an aesthetic look, and secondly, it enhances the lifespan also. If you have seen, if we are coating the walls of our house, if they were just cemented, the life and the look both are not so good. But if we just improve that using paintings, use nowadays that like deco paints are there, right? So just for those walls, the look and the vibes also for the thing gets changed. But now if the coating is done using some chemicals, if we are using that, definitely enhances the life and the quality of the product. Let's suppose now you were just talking about iron is being coated to get avoided from rust, right? get avoided from corrosion. So if the product is coated using chemicals, definitely if corrosion is being resisted, the life and the quality of product used is getting increased. It is not getting decreased. So there are two things. One is the additive technique and the addition of paint to walls, the chemical to elements is not an additive technique. It is just the coating, and coating can be done normally also, and coating can be done using chemicals also. So coating done on medicines like the capsules we eat, right? The medicines, the jo hum khate hain, medicines, they're also sometimes they're yellow, pink, white, blue in color. But that doesn't mean that chemical we are eating, the salt we are eating is yellow in color, is in blue color. So that is being coated to give it a, to give it an appeal that yes, मुझे ये खा के ठीक होना. That gives a good vibe in it, कि positivity that anything good can happen eating this medicine. So this is the same thing, but it increase if it is using then chemicals like coating using chromium, coating using titanium, using stylites. So this can help in wear erosion resistance, corrosion resistance, enhancing the life of the workpiece. So there are two things. What I understand from your question. I hope I'm clear, Shukla sir. I
Yes,
hope.
thank you, ma'am. Thank you, ma'am.
Okay. Thank you, sir.
Between the two terminologies clarified very well. Thank you, ma'am.
Thank you, sir. Thank you.
So thank you very much, Dr. Javeer Singh sir, Dr. Shukla sir, for your nice questions. Madam, you have answered it very well. So thanks a lot to you. Now I request the chief organizer of the series, Honorable Principal M. Ambedkar sir. Please come ahead and say some thoughts for us, sir. Please.
Thank you, sir. Thank you so much. And definitely, if given a chance, I'll present something new and more interesting than the other ones. Thank you, sir.
Thank you very much, sir. Now I move towards the vote of thanks. Sri Kumaraswamy Mahavidyalaya Ausa, District Latur, organized World Record Series 2. So for today's session, the topic was very interesting, need of an additive manufacturing. Though even this topic is new, but madam have explained it so nicely in an excellent way, where madam not only explained the topic, but brought the whole history and all knowledge has given regarding the topics, which is necessary to all human beings, as our principals said. So, madam, you have covered all those aspects regarding the topics. where the history of additive machinings, additive manufacturings, then working principles, the different benefits, and what are the constraints and all other features regarding the topic. So nicely, so madam, I'm very, very thankful to you. I extend sincere gratitude towards you. Thank you very much for paying a valuable time to us. Then I thanks to the chief organizer of the World Record Series 2, Honorable Principal M. Ambedkar, sir. I thanks the colleagues from my college, Dr. Sanjay Kale, sir, Dr. Anita Dole, madam, Dr. Karar, sir, Dr. Sudhir Garar, sir, Dr. Anita Dole, madam, Vocational Supervisor Praveen Utge, sir, and all others. Lastly, I thanks all their regularly joined participants, where basically Dr. Swanand Shukla, sir, Dr. Jaivir Singh, sir, those who ask every day, they shares in interaction session, ask some interesting questions, and a resource person may answers on that questions so nicely. So thanks to you, sir, being a part of interaction session. So thanks to you. And lastly, thanks to all their attendees, those who joined the series and makes us motivates and enhance the beauty of the series. Thanks a lot to you. Now, with the kind permission of the Honorable Principal, sir, Chief Organizer of the series, I declare that today's session is over. But I request to you all, please fill the feedback link which is given in the chat box. Not to miss. Thank you very much. Thank you, ma'am.
Thank you.